I saw a few videos on testing a rectifier regulator on a motorcycle, and I'm going to see if I can explain it more in detail. I have a computer science degree, but I've taken electronics formally. First of all, a rectifier regulator is similar to an alternator in a car, and if you know electric motors or the process of making electric, magnetic force is one of the methods of making electricity. The other way would be something like hydroelectric, nuclear physics, wind power, steam power, natural ways like natural gas, etc., coal. Magnetic pulse or electromagnetic force is another way to make electric, and those are typically used in automobiles and transportation due to the petrol fuel engine or the internal combustion engine. Now the stator. Well, let's go through a motorcycle. The motorcycle has what they call a stator, and that's basically a coil system with magnets. And if you know magnets and coils, when a magnet goes through a coil, it produces electromagnetic force and therefore electricity. Now let's start with the sine wave. Here is a sine wave. What is a sine wave? Well, a sine wave is nothing more than a graphical representation of electricity. In other words, you can't see electricity. I can't tell you what electricity looks like, but the mind operates on two levels. It operates on an image level, and it operates on a theoretical thinking level. A sine wave is the image level, the picture that conveys the theory of electronics and what happens at the atomic levels. So that's what a sine wave is. A sine wave is very important because it gives people a lot of leverage and a lot of flexibility to explore the theories behind electricity. Now, there are two types of sine wave. The first is a frequency. Frequency sine waves are basically how you measure the time intervals. Now, the top here is called the top of a sine wave. You can see that's called a crest. The bottom here is called a trough. Now, the frequency the frequency sine wave is important in radio frequency, but in this case we're looking at what they call there's frequency and there's amplitude. I forgot to mention the second one, amplitude. If you know frequency, frequency modulation is FM radio. Amplitude modulation is AM radio. I'm not going to go through and explain what amplitude and frequency means, but basically they're broken in time intervals, and that time interval determines the frequency and also the amplitude of the sine wave. Now, in your motorcycle you have what they call a Mosfet. And to briefly explain a Mosfet can be of two characteristics. First is to amplify. Okay? So you have a Mosfet amplification process. And secondly, it is to rectify. The rectifying process, excuse me, I have something in my eye. The rectifying process essentially is how we convert the AC current, which is alternating current, to the DC current. Okay, so that's what MOSFET is, just a form of these things, these processes. MOSFET is nothing more than a transistor, and a rectifier or a regulator is nothing more than a diode. Okay, so the original OEM has what they call a diode rectification process, where it only allows current to go in one direction. Now, what do I mean by a diode in one direction? A sine wave, or AC, okay, depending on the frequency, will change directions according to the frequency. So it's not only going in this direction, but it's also going in that direction. We do the graphical representation of it in a sine wave, but basically it's going back and forth, back and forth, back and forth, like that. So if you take the sine wave and flip it this way, you see the modulation of it like that. Okay, so that diode, what it does is it only allows one direction, that way. So what you get is what they call a square wave, and a square wave looks like this, and that's a DC current. This square wave right here also is similar to what they call a digital signal, because of its crest right here is just a 1 and its trough is a 0. Alright, so now you know what a diode rectification is. Diode rectification only allows one direction. Then you have the Mosfet rectification. Mosfet rectification uses transistors or active switches. Now, a transistor is nothing more than a silicone or a conductive material that has extremely low resistance. Okay, extremely low resistance. Alright, so it is a switch, and it turns on or off. And when the current goes this way, it goes on. When it goes this way, it turns off. And that's how it acts similar to a diode. It goes in one direction. Now, the good thing about MOSFET is that it does not... The good thing about transistors, what makes it good for amplification, is that it has low impedance. In other words, it doesn't have very high ohms or resistance. Now, when you amplify, okay, when you amplify, you produce a lot of heat. And if you know how a regulator blows up, basically the heat from the engine produces that resistance or impedance, and that resistance causes something that we call an avalanche. Okay, I'm not gonna go through what an avalanche is, but essentially what happens is, as the wave goes up, it hits this avalanche, and then it basically goes like that, straight down. It bottoms out. In other words, there's a threshold right here where the heat and the resistance causes failure. In amplification, we get that as electrostatic noise or white noise, but we're not amplifying. That resistance will cause an arcing, or it will cause the component to blow up. So that's why your motorcycle rectifier is blowing up. The MOSFET produces no heat, and it produces no heat because there's no resistance in it. In other words, as the electricity is flowing through there, there's no heat in there. Now, AC current was invented by Nikola Tesla. Okay, Tesla. And back then, AC current was extremely dangerous. However, it was the only way to move current, which is, well, hang on. It was the only way to move electricity from one point to the other in long distances. But the problem with it is it's extremely dangerous. So in order to cope with this, Nikola Tesla invented something called rectification, an inverter. An inverter is what you call step down transformation. Okay, basically you got a transformer and you're stepping it downwards. So you're going from a higher to a lower. When you rectify, or well, let's put it this way. The induction process can go either step up. Step up would be like you're going from 12 volts to 220 AC. Okay, that's an inverter. That's a reverse, that's a step up inversion, or a step up induction. Step down would be 220 AC to a 12 volt. Okay, that's called a step down. Similar to amplification, the induction process, okay, uses a transformer. They got coils on one side, coils on the other. If you're going 2 to 1 step down, you'll have one coil on this side, 2 coils on that side. So the induction process steps it down and vice versa. The induction process can step it up using those coil process. That's basically what a transformer is, what induction is, and what stepping up and down is. That's what's going on inside the regulator with the rectifier. Okay? The regulator keeps it going in one direction. The rectifier uses an induction process and it steps it down. So your rectifier is a step down induction using Mosfet, which is transistor, or an active switch, to control the direction of current. Now, what's current? Current is the measure of electrons. What's electrons? Electrons are a negative charged atom. Okay? So, you have current. Current is your measure of electrons. You have voltage, which is, wait a minute. What is your voltage? Measure of current, measure of electricity, voltage, the amount of current. Okay. Electrons flow. Okay. These electrons flow when there is a drop in the electricity. So let's say you have 1 volts here and you have 0 volts here. Electrons will flow from 1 to 0 because 0 is the lower number. You have a drop in voltage here. If you have 1 volt here and 1 volt here, you do not have a flow of current. Now, why does current flow? Current flows because of a physical property. It's called pressure. Okay, it's not thermodynamics, it's pressure. The current flows from a higher to a lower voltage because there's a drop in voltage, causing the electrons to flow in that direction. If the drop in voltage is the reverse, it will flow in that direction. Okay, so now we have our voltage, we have our current, we have our changes in direction, and we have our diode. A diode is a decent way to do it, but the only problem with a diode is the heat. Whereas the Mosfet, no heat. Okay? That's why Mosfet, when you amplify, is a very good, if not the industry standard. And they come in semiconductors. They come in these computer chips. A Mosfet is just simply active switches. Those active switches, you know, when the electricity is going like this, it goes on, 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 on. So it's an active switch, unlike a diode. A diode's a passive device, which means that it does not move, or it does not have any physical movements in it. Now, the rectification. So, well, okay. So that basically gives you an idea. Okay, you have your stator, which goes round and round and round. You have your magnet and coil. It goes into your rectifier, regulator, which can be diode or Mosfet. Okay. Then from your rectifier, it goes to your battery. Okay. It charges your battery, and then it also goes to your system. Okay. Now, let's see. Have I covered everything? I think I covered everything. So, okay, let's do a summary. Let's do a summary. Okay. From your stator, you have your coils and magnets. That produces a flow of current because the magnet goes through the coil. That flow of current, which is nothing more than a drop in pressure, voltage. Voltage is your measure of current. Okay. Current is nothing more than the flow of electrons, and the flow of electrons is not an electronic process. It is a physics process. It is a drop in pressure. Higher goes to lower. Okay? Similar to thermodynamics, the laws of thermodynamics. It always goes to the lower. It never goes to the higher. In electricity or in this pressure, it always goes to the lower. But don't confuse the two. All right. Now we have the rectifier regulator right here. The problem with the diode is it has heat. Heat causes resistance. Okay. That resistance then leads to failure, which is what I describe as avalanche. Avalanche, if you want to look it up, it is a common term when you amplify, when you do amplification. Now, when you amplify, let me go through some of this stuff real quick. Let's talk about amplification. Okay, amplification. All right. Amplification is nothing more than stepping up. Okay, you're stepping up using what they call a capacitor circuit and induction. It's a transformer. It's the same thing as a transformer. You step down, step up, you're stepping up. But in a sine wave here, you have both the crest and the trail. And then you have time intervals, which determines the frequency. Okay? You can manipulate any of this. If I stretched out the wave, you got 2 seconds, you got a longer wave. Alright? So what am I trying to say? I'm trying to say that an AC current is like that. Okay? Crest, trail, AC. The problem with AC is it's dangerous. So you have to switch it to a low circuit power. And that's DC, or direct current. AC goes back and forth, back and forth, back and forth. DC is more like a square. Okay? Now, this is not related to any of this, but DC is important because you get into what they call pulse modulation. Okay? Pulse modulation applies to both an analog or a digital signal. Roger that? Alright. Now, pulse modulation. I'm going to go through pulse modulation real quick, and I'm going to finish this. Pulse modulation is in 3 forms. Okay? Pulse modulation. Oh, wait a minute. Okay. Pulse modulation is how you get FM and AM. Again, I said there's two types of sine wave. Frequency or amplitude. That's the sine wave. There are 2 forms of sine waves. Frequency modulation is when you place data onto this wave. Okay? So you'll have another wave inside the wave. You understand what I'm saying? There's a wave inside the wave. Now you have a three-phase rectifier. I think this is what they mean by a three-phase. You've got three stators on there, which means that it gives 3 sine waves. Now why is that? So you're getting 3 signals. You're getting 3 signals from there that comes in and it becomes 1. It doesn't matter, because the transformer and the rectification process converts it all into 1 DC current. So it doesn't matter whether you're getting a 4-phase, 3-phase, 2-phase, but I believe it has to do with the amount of the stators, or the coils. So I think that's where the 3-phase comes from. Whatever the case. Why am I explaining to you frequency and amplitude modulation? Okay. Digital modulation. Okay. Digital modulation is very similar to a DC current. Now in a DC current, this crest here measures your amplitude. Okay. So this may be 12 volts. So that's a DC current wave. In a digital wave, that same wave represents 0 here and 1 up there. So a DC wave has the same physical properties or graphical representation that a digital wave has. So does that matter in your rectifier regulator? No. Does it have the same same wave property? Yes. And therefore, that, I hope that kind of explains it. When you have frequency modulation, you have a wave inside a wave. It can be another wave, okay? Or it can be another wave. When you encrypt it, let's not get into encryption. When you encrypt it, what you're taking this information, you're scrambling it up, and you're changing the frequencies, and you're changing the amplitudes in there, and you're having a math formula, x plus x equals y, and only you know how